I came across this tweet, and this is not the first time actually coming across it. This is almost like the third time I've seen it, and people do it as a joke. So I'm not sure if they do it as a joke, or some people actually believe that it actually makes sense. Because I've gone through the comments, and most people are just laughing about it, like I don't know. Because the first time I saw it, like I can see it, and I know I can't relate to it because in my mind I know the logic is flawed. It doesn't make any sense. So he's talking about Schrodinger's plates and says that both broken are not broken until you open the door. That is very wrong. Yeah, when you open the door, they are broken, and when you close the door, they're not broken. Like you already know they're not broken, and you know they're going to break when you open the freaking door. Like it's not. There is no uncertainty there. Everything is certain. I can see through the door they're not broken, and I know that, and I open the door, they're going to break. And Schrodinger's cat is not about that. So for anybody who doesn't know about Schrodinger's cat, so this is about quantum mechanics. So leave alone all the quantum mechanics shit. So basically, it says Schrodinger says that in order to illustrate what you call a quantum superposition, yeah. So quantum superposition. So imagine this: I have a box, an enclosed box, and then I take a cat and put it inside there. And obviously, the box has air, so there's enough air to breathe. And then what I do is I take a radioactive substance, yeah, whose half-life is unknown. So I don't know the half-life. So if you have no idea what half-life is, it's the time it takes for the atoms of that radioactive substance to decay. And once it decays, obviously it kills the cat. So if I take a radioactive substance and put it inside there with the cat, whose half-life is completely unknown, the half-life could be 3 days or 2 hours or 90 days or 3 years. We are not sure. But because we are not sure of the half-life and we put it in a close, so once we close that box, we are not sure of the state of the cat. We are not sure whether it has already fully decayed and killed the cat, or it has not decayed and the cat is alive. So the only time we'll be sure that about the state of the cat is when you open the door to look at the cat. So that's when you'll know if it's alive or it's dead. So this doesn't illustrate that, because this is very certain. I know I look through the glass, they're not broken, and if I open them, they're broken. Yeah, so that is what Schrodinger's illustrates. So it's basically what you call a qubit. Yeah, so in quantum mechanics and quantum computing, a qubit is the fundamental compute in a quantum mechanics quantum computer. So it means that a qubit is always in a superposition state or in a spectrum until that point when we try to observe it. So when immediately we observe it, yeah, it collapses into one of the fundamental states, 0 or 1. That's basically what it is. Yeah. So think about it. I think I have an analogy. Think about it like this. I can bring my own analogy. Think about it like that. You have a kid. You're a kid in your room, right? You're a child in your room. Yeah. You're a kid in your room, and I mean, let's say you're supposed to be. It's nighttime and you're supposed to be sleeping. Yeah. So it's nighttime and you're supposed to be sleeping. Yeah, you're supposed to be sleeping. Okay, my analogy isn't making sense. Let me stop with that. Let me find another analogy. I don't want to correct somebody's flawed logic and introduce my own pathetic shit. Okay, thank you.